So, dear students, now we will study the intensity of the spectral lines. What is meaning of intensity? If suppose you obtain the spectra is like that, and okay, like that spectra, you suppose you obtain, and that particular points, okay, that you said that particular frequency is, if suppose epsilon, and you found that is the higher intensity, okay, intensity against the frequency, it is having the lower intensity, lower and middle intensity, and that particular intensity, okay, the frequency is given by the detectors is a different intensity is there, and that intensity of spectral line, we can, it depends upon the three factors, and those three factors are, first is the probability of okay, first is the transition probability, second is the population of energy levels. Okay, first is transition probability, and second one is the population of energy levels or the states, and third one is the its path length and concentration. Okay, these three factors decides the intensity of the spectral line. Which spectral line is the higher intense, we can find out by using these points. Okay, first point, the transition probability. If suppose you have the energy levels, and if you are first from that energy level, you excite your energy from first to the other, okay, that excitation, probability of that excitation, probability of excitation. Okay, just like your weather department said that particular time rain will be appear, like that probability of raining will give by the weather department, climate department, like that probability of excitation can be calculated by mathematically quantum mechanics. By using the quantum mechanics, we can predict some mathematical treatment is given. By using that treatment mathematic formulation, you can predict whether that particular transition is probable, is possible, is given by that quantum mechanics. Okay, if suppose if your probability is less for excitation, it means it is the less intense. Okay, probability of excitation from one to the other is less intense. Or if probability from first energy level to the other energy level is zero, okay, suppose not possible. If probability of excitation from one energy level to the other energy level is not possible, it means it is a forbidden transition, and it will not appear in our spectral lines. And if your transition, there is a non-zero transition, okay, from one state to the other state, that is a non-zero transition is there, it means the transition is possible or allowed transition, it is called as the allowed transition. Okay, zero probability of the excitation from one energy level to the other energy, the forbidden transition, or non-zero transition, zero probability means there is a transition possible from one energy level to the other energy, that is allowed transition, that is called as the allowed transition. And these quantum mechanics of this allowed transition or the forbidden transition will further gives the selection rule. By using the selection rule, we can predict whether the excitation first energy level to the other energy level is takes place or not takes place. Okay, by using these particular things, that is a transition probability, it also depends upon the it also gives the intensity of the which line is the less intense and which line is zero intense, which line is something intense, will be given by the transition probability. The second one is the population of energy levels or the states. Okay, second we have to second point, population of energy in a states. Okay, if suppose you have the number of states is there, and at the last states, if higher it's populated is higher. Okay, if suppose the number of molecule is present at that level, some very few present at that level, and very less is present at third energy level. When excitation is takes place from first to the second energy level, number of molecule is there, number of molecule excited is there, number of frequency is radiated is more, therefore its intensity is higher. In this case, two molecules only in this level is there with excite to this that second level, therefore its intensity is less than first energy. If a very small, very one molecule is present at third energy levels, and this gives the very less intense frequency in our spectrum. Okay, therefore the population of energy states, okay, number of molecule is present that energy, it means the higher that level is the higher populated of that molecules, therefore higher populated energy levels give the higher intense lines in our spectrum. Okay, suppose through how to decide the molecule is present at the first energy level, second energy level, third energy level, fourth energy level, there is a Boltzmann energy distribution law is there, and that law gives the nth energy levels, how many molecule is present, is given by C raised to minus E energy of ith level upon kT Bolt distribution constant and at a particular temperature. Okay, and that n is the number of molecules at ith energy levels. If suppose at this is 1, 2, 3, okay, this is third energy, n3 molecules. Okay, at n3 energy levels, how many molecule is present will be given by this Bolt distribution law. C is a constant and which depends upon the concentration of molecules, how many molecule actually present by using these numbers. If suppose 1000 molecule is present, that 1000 molecule total molecule, you consider the total molecule, this constant, it depends upon the total molecules. EI is the energy at the ith level. Okay, if suppose your molecule is present third level, therefore the energy of E3 will be you consider in this case. K is the Boltzmann constant, T is the temperature. Okay, therefore by this equation predict at which levels, at which temperature, how many molecule is present, and which we will use for the decide which frequency has the higher intensity. Okay, that is the points, our second point. By using that point, we can predict the intensity of lights, and each lines is not same population of the molecule. Each line has the different population of the molecule, which given by the Boltzmann law. As the temperature increases or decreases, the population of the energy levels will be goes on increasing or will be goes on decreasing. The intensity higher means the population of that energy level is higher. That is given the higher intense frequency in our spectra, and thus the intensity depends upon the number of population present in a particular energy level. Okay, that is second point. We have studied the population of energy states, and also the intensity of our spectrum is also depends upon the path length and the concentration. Okay, if suppose your path length, that is your path length and that is your sample, and some particular concentration, and P is your path length. Then Beer's-Lambert's law we have studied. Absorbance is directly proportional to the path length. Absorbance is directly proportional to the concentration. Okay, that is absorbance is also proportional to the log 1 upon T, that is minus log T. Okay, that is also one of the points we have studied. Log, okay, absorbance is not proportional directly is equal to minus log T, and which is absorbance is also given by the log P0 upon P. P0 is nothing but the what you call it's radiant power of what you call the P0 is radiant power of incident and the radiant power of transmitted light. Okay, P0 is radiant power of incidence light and radiant power of the transmitted lines. Okay, by using this okay, by combination of this law we have studied in analytical chemistry is equal to epsilon B. Combination of Lambert's-Beer's law is given by the epsilon BC. Okay, Beer's law is depends on concentration. Okay, E is directly proportional to the concentration, and Lambert's law is depends upon the path. A is the directly proportional to the path, and combination of these. Okay, therefore absorbance is depends upon path and the concentration. If concentration is more and path length is more, the absorbance is more and intensity ultimately increases. Okay, because if sample is absorbed, if sample path length is more, then more time is that particular light will goes from this sample, and more time it will remain in that sample, and therefore the sample will get sufficient time if path length is higher, and therefore it absorbs the sufficient frequencies and it emits the sufficient frequency, and its higher intensity is observed in spectral data. Spectral lines is higher intensity is obtained when path length is more, and concentration if it is more concentrated, which is it gets the more ability to absorb the frequencies, and therefore more ability to absorb the frequency due to more concentration is there. The spectral lines is the more intense you will obtain in your spectrum. Okay, like that way we can predict the intensity in a spectral lines. Thank you very much.